Hi guys, so the emails have been read and looks like you guys wanted to do more problems on how to write a logarithm in expanded form. So let's do this. I got two more brand new problems. Let's do them and then be on our merry way. So we are asked to use the product, quotient, and power rule of logarithms to expand each logarithm if possible. Okay, so the question is, when is it that we can expand them? If we are having a moment, let's vent out our frustrations, but on paper, okay? So I'm like, silly logarithm rules, they make me so mad. So we can expand a logarithm if the argument is a multiplication problem or the argument is a division problem, okay? If the argument is a multiplication problem, then we're gonna split the logs as an addition problem. But if the argument is a division problem, then we're going to split the logs as a subtraction problem. So let's go ahead and look at the argument. Bear in mind that the fraction bar is also used as a division symbol. So in this case, when we split the logarithm, let's use our fancy words. When we write the logarithm in expanded form, we're going to write it as a subtraction problem. So how? We're going to write it as log of the numerator subtract minus log of the denominator. So let's do this. Log of the numerator minus log of the denominator. Okay, now I understand myself, but the way I have written this in paper, the only thing we're taking the logarithm of in the second part is y. Okay, after that, then we'll just do a minus 1. In this case, it's important to put parentheses. That's the only way the reader will know that the argument is actually y minus 1, not just y, and then we'll subtract the 1 at the end. Cool. So we have expanded it, okay? So, but the question is, can we expand it more? I don't know. Let's look at each argument, make sure that we don't have products or quotients, and then make sure we don't have any exponents in the argument. Next argument, we have 8x squared. If we enunciate the operation, this reads 8 times x squared. So I was like, we can expand it again. So let me vent out my frustration. And then a quick reminder that if the argument is a multiplication problem, then when we expand it, we're going to expand it to an addition problem. How? Log of the first factor plus log of the second factor. So let's go ahead and do that. Log of the first factor. Remember to always maintain the base, even if it's just a variable. Log of the first factor, multiplication plus, okay? Log of the first factor plus log of the second factor. Cool? All right, let's look at the rest of this puzzle. Can we expand this other logarithmic term? I don't know. Let's look at the argument. Is the argument a multiplication problem? Is the argument a division problem? Y minus 1 is not a multiplication problem and it's not a division problem, so we cannot expand it. So now I'm like, wow, is the argument being raised to a power? And if so, we'll use the power rule for logarithms. But this bad boy is not being raised to any power, so that's simplified. So let's bring it down. Minus log base b of y minus 1. So we have done an excellent job of expanding the logarithm. So remember, when you're asked to expand the logarithm, that's just code for like write it as the sum or difference of logs. Cool. Now let's see if we could tone down any of the logarithms. We have a logarithm base b of 8 that cannot be simplified. The product is not a multiplication problem. The argument is not a multiplication problem or division problem. Is 8 being raised to some power? No, so that's simplified. Next, logarithm. Let's look at the argument. Same speech. We cannot expand it, but we can definitely rewrite it. Why? Because the argument is being raised to some power. So we don't want exponents in the arguments. So we're going to use the power rule for logarithms to bring the exponent down. How? What would that leave us with? So that's going to leave us with 2 times the leftover logarithm. 2 times logarithm base b of x, and then we'll bring down the rest of the problem. So we are subtracting from it log base b of y minus 1, and this is being added to log base b of 8. Cool. I think we finished it. Let's look at the new new argument. Yeah, we cannot expand it. Why not? Because the argument is not a multiplication problem or a division problem. We cannot rewrite it because there's no exponent. So I think we nailed it. So I will give you full credit for this. But if the raised dot is getting in your way, then go ahead, rewrite it without the raised dot. It's really a personal choice. Alright, I should have had like some music in the background while I rewrote this, huh? Okay, so with or without the raised dot, it's a personal choice. Okay, guys, so I promised you 2 more problems. That was our first of the 2 problems. Let's go ahead, do the second and final problem, and then we will be on our merry way. Okay, so don't forget to pause and rewind as many times as needed. Okay, problem B, we have log base 4 of this quotient. So we have 4th root of x times 5th root of y cubed, and that's all over z squared. Yeah, I'm not gonna lie, this is pretty very tedious looking, or whatever I'm trying to say. It looks intimidating, but you know what, we just gotta see this like those puzzles that have 1,000 pieces. We just gotta take it one piece at a time. We are asked to write this in expanded form, so write it as like a plus or minus. Now, can we really expand it? What if it's a trick question? So let's vent out our frustration. Silly logarithm rules, they make me so upset. Okay, but we're gonna say they make me so mad. So let's look at the argument. If the argument is a multiplication or division problem, we are expanding. Okay, the fraction bar is used as a division symbol, so guess what, we are expanding. And when we do, we're gonna expand it to a subtraction problem. How? We're gonna say log of the numerator subtract or minus log of the denominator. Yeah, you can't see that yellow, my mistake. So we have log of the numerator, it's gonna take me a while. Now I want to make sure that I don't confuse myself, so we're gonna wrap up this product. Log of the numerator minus log of the denominator. Okay, log of the numerator subtract minus log of the denominator. Let's look at our new terms and see if we can expand those. The first argument is a multiplication problem. Guess what? We are expanding. So silly logarithm rules, they make me so mad. If the argument of a logarithm is a multiplication problem, then when you expand it, you're going to expand it to an addition problem. So how? It's going to be log of the first factor addition plus log of the second factor. So let's do this. Log of the first factor, we said add, plus log of the second factor. Cool. Hopefully I copied everything correctly. Log of the first factor plus log of the second factor. Alright, let's bring down the rest of the puzzle. Okay, the second term in the step above, the argument is not a product or division problem, so we cannot expand it. So we cannot expand anymore, but we can definitely rewrite these terms. How? The first argument, or when we look at the first term with the log, the argument has a hidden exponent. So let's go ahead, take it, rewrite this in an exponential form. Okay, remember, whenever we have a radical, let's code for hidden exponent. So we have logarithm base 4, and to write the 4th root of x in exponential form, we are going to take the base and write the exponent as a fraction. How? Current exponent divided by the index. Cool. Alright, let's put the next argument in exponential form. Okay, so we have plus log base 4, and to go from radical form to exponential form, we're going to keep the base and write the exponent as a fraction. Current exponent divided by the index, and then we'll just bring down the rest of the puzzle for fun. So we have log base 4 of z squared. Okay, now we have established that we cannot, pretty much we cannot continue to expand or split the logs, okay? None of the arguments is a multiplication problem. None of the arguments is a division problem. So we cannot continue to expand or split the logs, but we can rewrite the logs. How? We're going to use the power rule for logarithms. For the arguments, we always want to present them as clean cut as possible. So if the argument has the exponent, we got to get rid of it. Okay, so let's go ahead and use the power rule for logarithms to tone down the argument. So the first, for the first term, we're going to bring down the exponent and then multiply it by the leftover logarithm. So that will leave us with 1/4 times log base 4 of x plus another argument that has a power. So let's go ahead use the power rule for logarithms. So that will leave us with 2/5 times the leftover log. So times log base 4 of y. Okay, minus, you guessed it, we have another argument that's being raised to some power. So let's go ahead for the third and final time, use the power rule for logarithms to rewrite this. So to do that, we're going to bring down the exponent and then multiply it by the leftover logarithm. Okay guys, so I promised you 2 more problems in expanding the logarithm. That was our second and final problem, so we're good to go. Thanks.